let's take a look at filtration. Okay, so imagine, for instance, you're filtering water at home, but you use this pressure. That's what filtration means. So we have two pressure that helps filtration in our system. One of them is coming from our blood. It's called a blood hydrostatic pressure. Okay. Now, so the blood hydrostatic pressure are those that are traveling the blood, and the volume of the blood mostly made up of this keyword, hydro. So what does hydro mean? Right, it means water, H2O. So that means the water inside your blood creates a lot of pressure to push materials and fluids from the blood to the tissue. Okay. So that is usually about, when they measure it, about 35 millimeter of mercury. Okay. Now, the other thing that also helps with filtration are the interstitial fluid osmotic pressure. So what does this mean? Yeah. Now imagine these are the cells in your tissue region. So in between them are the fluids, or we call the interstitial fluids. Okay. So what are present in these interstitial fluids, for instance, create the osmotic pressure. So a lot of times those are, for instance, the proteins that are in between the cells, the ions in between. So mainly the solids that are dissolved in water that are creating it. So when you have proteins in between the cells or the ions, they attract water to go toward them. And it's a smaller number, about 1 millimeter of mercury. So these two, the water in the blood, pushes things out, as well as the protein in your tissue, between your tissue cells, also attract water and fluids for filtration. Okay? Now let's take a look at the opposite side. So for reabsorption, we have two pressures that helps reabsorption. We have the blood colloid osmotic pressure. So colloid means a colloid solution are opaque, they are not clear because of what's present in them. So if you think of milk is a colloid solution. And so, for instance, osmotic pressure is depending on the solids that are present in the blood. Yeah. So in our case, what are they then? The solutes in our blood, there are a lot, but a lot of them are the proteins. Okay, for instance, our albumin, we see a lot of them in the blood as well. So what they do when you have proteins in the blood, they also help attraction, fluids moving from the tissue to the blood vasculature. So this is about 26 millimeter of mercury. Now the other one that also help with reabsorption are the interstitial fluid hydrostatic pressure, because in between your cells there are water as well, so some of them will help push the fluid back in as for reabsorption, but it's quite little or sometimes so close to 0 millimeter mercury. Okay, so everyone okay with these? Now we're going to put it all together. So we're going to take a look at the arterial end, so which is at the red end, where you have a lot more oxygenated blood in your red blood cells. So here is an equation we can calculate for the net filtration pressure, or NFP. So what it's equal to, it equals to the pressure promoting filtration minus the pressure promoting reabsorption. Okay? So if we remember, those that promotes filtration are the water in the blood, pushes things out. Also, the protein in between your cells helps as well. So together it's 36 millimeter mercury. Now pressure promoting reabsorption, of course, are protein in the blood as well as the water in your tissue. Okay, so if we add those together, it's 26. So 36 minus 26 equals 10 millimeter of mercury. So the key point is what I want you to is know this value. Okay. Now when we set up our equation like this and it gives you a value, for instance, it's 10 millimeter mercury or a plus sign, yeah, a positive number. So what does this tell you? Did filtration win or did filtration win or did reabsorption win? Right, at the arterial end, if it's a positive number, that tells you filtration is a much bigger number than reabsorption. And that's exactly what we want happened at the arterial end because we want the goodies, the oxygen, to go to your tissue. Okay? And we want the nutrients to go towards your tissue. Of course, there are reabsorption going on, but not as strong as your filtration. Okay? So most of the pressure would push fluids to go to your tissue site. Everyone okay? Now we're going to take a look at the venous end. So here we have the same equation, yeah, which is your net filtration pressure equals pressure promoting filtration minus pressure promoting reabsorption. Okay, so over here we still have filtration going on, okay, but it's a little bit weaker. Yeah, so 16 plus 1, 17, minus those that favors reabsorption. Okay, so remember, so we add up these are my 26. So 17 minus 26 equals, is it a positive or negative number? Right, it's minus 9 millimeter of mercury. So does this favor filtration or does it favor reabsorption? Right, it tells you at our venous end where reabsorption is a much bigger number, reabsorption wins. So, okay, so most of the things, for instance, your waste product, CO2, gets to be removed from the tissue back into the blood, and eventually everything back to the heart. Okay, so make sure you know what the net value means. Okay, if I ever give you anything like this on the information festival, I will give you all the definition as well as the number, but make sure you can calculate and know the significance of the end value. Yeah. So if we put it all together, it looks crazy, but let's break it down because you already went through some of these. Yeah. So if we take a look at our equation over here, which we saw earlier, okay, so this tells you, or describes the Starling law of the capillaries. So basically, you have the pressure promoting filtration minus pressure promoting reabsorption. Okay, and at the arterial end, do you remember our net filtration pressure? What was that? Right, it was 10 millimeter mercury. So did it favor filtration or did it favor reabsorption? Right, it favored filtration. Now on the venous end, we had minus 9, right? So this tells you it was favoring reabsorption. Okay, so when we put it all together, the whole ideal is you have things going out of the blood vessel, you have things going in. But at different places, for instance, filtration favors more at the arterial end, reabsorption favors more at the venous end. Now, totally every day you will filter out 20 liter of um, solution, and about 17 of them will return. Okay, so very, very important system. And we're going to take a look at what about the remaining 3 liter of fluids then, right? What happened to them? So let's take a look at something called edema. This is when filtration wins over reabsorption. all the time. Okay, so what happens here then? So, okay, now normally, okay, when we have fluid that are not reabsorbed, we said 20 liter comes out and 17 returns. So normally we do have about 3 liter of fluids that are not reabsorbed. So what happened to them normally then? Right, it can't stay all the time at the tissue cells because we got to remove them. They actually go to here, your lymphatic capillaries. So eventually they go to your lymphatic system. Okay, so that's why they're quite important. And before we return any of the fluids back to the heart, there are, for instance, immune cells in here waiting for any pathogens in your system, and they will chop, chop, chop. Make sure they degrade those pathogens, and before we return all the blood fluids back into the blood. Okay, so in the case where edema happens, it have a hard time returning these back into the system. And supposedly sometime if filtration is so strong, for instance, and your reabsorption is weak, so a lot of time depends on how your kidneys are working, your renal system, and sometimes it depends on your diet as well. So if you're malnourished, malnutrition, also, for instance, you will we see edema happen because when you have less proteins, nutrients, less protein in your diet, they are also going to make less protein, for instance, like albumin in the blood. So as a result, when you have less of them around, they have a harder time attracting the fluids back into the blood as well. So you see a lot of time when they have commercial or diagrams of poor little children who doesn't have a good balanced diet, or they just simply don't have access to food. Their tummy is quite big, and so it's a lot of swelling of their tissue because they don't have enough protein in their diets. Okay, and it is reversible. So if they are have food to eat, a good balanced diet, then the process will be reversed. Okay, and we'll see this on the next video lecture.